Now we're going to basically do the same thing. Here it says write as a single logarithm. In part A, we see two things happening. We see a log plus a log. We also see a number out in front of the log. Okay? Now, you're going to be tempted when you see adding to quickly put them together with multiplying. I'm going to rewrite out the multiplying log law. The log law says that you can combine them. When you're adding, you can combine it as multiplying only if there are no numbers in front. See how it's just log m plus log n? There's no numbers in front. So we've got a problem that we can't use this one yet because there's a 3 in front. But we have a log law that says if there's a number in front, you can put that in as an exponent. So if I did that as my first step and put that 3 in as an exponent, now I have a log plus a log, and I can combine those by multiplying. You can put it in brackets if you want, and now it's a single logarithm. And if you can go right to the end, that would be fine. Because it's not hard to see that I'd put that in as an exponent, and then I could combine. In fact, you'll probably get good at these that you'll do most of them in just one step. Okay? For the second one, you would have as two steps. First of all, there's a number in front. So I'll put that in as an exponent. There's a number in front here. So I'll put that in as an exponent. So before you can add or subtract, you have to put those numbers in as an exponent. Now I could do this in two steps, but if we did it in just one step, you're going to find whenever you're adding, that's multiplying. Whenever you're subtracting, that's dividing. So if we put this all together, well, the first two are multiplied, and the last one is subtracted. So that's divided in your expression. So I'm going to give you one in between before we do C. I want to see if you can do B.5 in one step. See if you can see these patterns and combine them all in one step just to get the answer. All together as a single logarithm. You have to decide what's going to be on the top of your fraction, because that's multiplied, and what's going to be on the bottom. The adding things are all going to be on the top, and this one's going to be a squared, and this one b cubed. The subtracting ones are going to be on the bottom, and so there's going to be a c and a d to the 4. And that's how you can do it all in one step. And if there was even more of them, and it doesn't matter the order, whatever is subtracting is going to be in the bottom of your fraction is divided. Whatever is added is going to be in the top, and then the numbers in front would be the exponents. And for part C, log base 2 of 6 minus 3. You want to write this as a single logarithm. Problem right now is there is a 3, right? That's not a logarithm. It's just a 3. But we learn in math that we can manipulate things, right? You could write 3 as 2 plus 1. That still wouldn't be a logarithm. but you could do that if you wanted to. The question here is, I know that I can combine things if I have logarithms with the same base. So if I could somehow think of writing 3 as log base 2 of something, I just need to make this equal. So we go off to the side here, because I don't know what to put in for x. And when it's in this form, I'm not used to it. But I can always change a log to exponential form. So in exponential form, well, the base is 2, the exponent is 3, and the answer is x. And now I see, if I look at it this way, could I figure out what x has to be? And 2 cubed is just 8, so I know that there has to be an 8 here. So I change the 3, which is a nice number, into log base 2 of 8, which is not looking nice at all, but helps me in this question. And now, because I'm subtracting, and the bases are the same, I can combine this as log base 2 of 6 over 8, which you could reduce if you wanted, but you wouldn't have to. Questions you can do for this one are 5, 8, 11, and 18.